Have you ever wondered how machine learning algorithms visualize high-dimensional data? It's like trying to comprehend the vastness of the universe from our tiny blue planet. But don't fret. There's a technique that makes it possible. Sammon mapping. Imagine you're holding a large, squishy, multicolored Play-Doh ball. It's a mess of colors and shapes, and you can't really tell what it's supposed to be. Now imagine you could squish and mold that Play-Doh, carefully preserving the distances between the colors, until you have a flat, two-dimensional picture. That's essentially what Sammon mapping does with high-dimensional data. Invented in the late 60s by John Sammon, this technique is a non-linear mapping algorithm that transforms high-dimensional data into a two-dimensional space. It's like a cartographer creating a flat map of our round Earth. But instead of continents and oceans, we're dealing with complex data. The magic of Sammon mapping lies in its ability to maintain the relationships between data points during this transformation. It's like our Play-Doh analogy. When you flatten the Play-Doh, you make sure the red and blue remain close together and the green and yellow stay far apart, just like they were in the original ball. Sammon mapping does the same, preserving the distance between data points in the new, more understandable, two-dimensional form. So how does it achieve this? The trick is in the error function it uses. This function measures the difference between the original distances in the high-dimensional space and the new distances in the two-dimensional map. The aim is to minimize this error, ensuring the new map is as accurate a representation of the original data as possible. But it's not all sunshine and roses. Like any technique, Sammon mapping has its limitations. It can be computationally expensive, meaning it takes a lot of resources and time. Also, it can sometimes distort the distances between far apart points, making them appear closer together than they really are. To sum it up, Sammon mapping is a powerful tool that allows machine learning algorithms to visualize and understand high-dimensional data by transforming it into a two-dimensional space. It's like the cartographer of the data world, creating maps that help us navigate the complex terrain of machine learning. However, like any map, it's not perfect and has its own set of limitations. So the next time you're faced with a big, messy ball of high-dimensional data, remember the Play-Doh. And remember Sammon mapping, your guide to understanding the complex world of machine learning data.